Welcome to the last module of this course. By now we have learnt about components that make up a robot like actuators, their drives and sensors. You learnt about kinematics, statics, dynamics, motion analysis of a robot. You learnt how a robot is installed, calibrated and controlled. Overall, you have learnt how such a powerful robot, which are quite often very big, is created and it is put to use. Before putting it to any industrial floor and programming it to its full potential, there are various safety guidelines to protect the environment, the people working around, and the property. Okay, so let us begin. Let us begin with this module, robot safety and programming. Okay, so let me just brief you about the overview of this module, what all things that we are going to cover in this module. So we'll be talking about workspace and operator safety, safety triggers and functions, workspace monitoring and marking forbidden zones, that we have seen it earlier also in one of the module when we have restricted the joint axis to move to certain angles only, where you can exclude one of the workspace from the robot to getting in. Okay, so that was one of the way. You also learned how to exclude in Cartesian spaces as well. Okay, external and internal safety devices, norms and regulations we'll discuss all this in today's class, and we'll learn about industrial robot programming. So before we actually get into the today's lecture, let me just demonstrate how a typical industrial scenario look like, how an industrial robot is placed inside the cage, where are all the safety devices are kept, where are the controllers kept, and just watch this video and you will understand. Okay, so you see this is a robot which is placed inside a cage. Top view of that from one of the isometric view, you can see this now. So this is the place where you normally place your teach pendant over here. Okay, so with this teach pendant you normally program your robot. Okay, so it is a quite ergonomically designed pendant with 3 position safety switch to simplify programming. So we'll discuss about what 3 positions actually mean and what are the functions that is given by this switch and different switches which are mounted on this teach pendant. Okay, so this is a teach pendant which is kept here, and you see this is robot controller. We have talked about industrial robots, its accessory in the introduction module also. So this robot controller, basically it's a controller which actually is a hardware that controls the robot, that has all the electronic circuits within, which you also have a PC which is inside. So that is normally having an operating system. Okay, so a proprietary programming software which conforms to the industrial programming architecture is actually installed, and the rest of the add-on tools are manufacturers specific. That we'll talk about industrial robot programming and others in the next lecture. Okay, so this is your robot controller, and then you see this is area sensor. This is the sensor with which you can detect any motion, any movement of any object if it gets into the robot work cell. So that is the area sensor. It is basically a laser range finder like that. And this is light curtain. You see there is a red strip over here that basically emits laser light, and that falls on the other side of it, which actually detects it. Okay, so if anything that crosses this invisible curtain, it gets detected and the robot stops, or whatever if it is programmed to do, it will do. Okay, so this is a light curtain. And this is where you have the operator station, where you have push button or touch screen display that is used as an interface with the robot cell to facilitate user intention, that is normally to interact with the robot through this electronic device You can do it from here. Okay. And then you have safety fence and flash curtains. Finally, you have a cleaning station. This is specific to welding robot, where a robot moves to the cleaning station for periodic cleaning of the welding gun. But it can be a tool maintenance station also, where you can have a spot welding gun getting cleaned or a painting gun getting refilled. This is right inside the cage. And you have power supply. This power supply is designed specifically for robot welding in a wide range of application. This is specific to spot welding, but it can be a power supply for spot welding also. So this is a place which is outside to the cage. Okay, so this is how a typical industrial robot is placed, and it is covered with various safety functions, safety switches, and the accessories, okay, which makes it fully functional. Okay, so let us begin with the today's class. So yes, introduction to workspace and operator safety. Industrial robots are built with best in technology available today with the recognized safety rules. Normally they are made with whatever best you can do, that is now utilized to make such robots. Okay, so yes, that has almost everything that you can find in an industry, because you see industrial scenario is very much demanding in nature to increase the product life cycle, to increase the production, to increase your workflow, to facilitate the workers, to work with the environment, to work with the robot. So it has almost everything that best you can find in today's scenario, because money is not always a limitation in industry if it can increase the productivity to a high volume. Okay, so yes, that is always there. And recognize safety, which is if it is designed to date, so all the safeties which are recognized till date is utilized to make such robots. Okay, yes, the intended use, that is the purpose of the robot, is clearly defined in the robot's technical data sheet or the manual. This we have discussed earlier also while we were discussing the technical specifications of the robot. So as per ISO standard, this is to be mentioned. If it is for a welding robot, it is a painting robot, or whatever is the purpose that should be clearly mentioned in the data sheet of the robot. Okay, any impermissible misuse, that include use of robot for transportation, that should not be done. Okay, you can definitely climb on top of the robot and go from one place to other, but that is not an intended purpose and it is not allowed. So if your robot malfunctions due to this reason, definitely it is out of the safety boundary, and nobody will guarantee that robot performs to its fullest, or you are safe in that case. Okay, for climbing purpose, to go from lower floor to the upper floor, if the robot is big enough, you could do that, but it is not meant to do that. In outdoor operation, if it is not mentioned in the purpose of the technical manual of the robot, it should not be used for the outdoor environment. Okay, in potentially explosive environment without any safeguard, this type of robot should not be used. Okay, it should be used only by trained personnel and in accordance with the guidelines provided by the manufacturer. The performance of the robot is guaranteed if it is working with the guidelines provided by the manufacturer. Okay, any planned maintenance or any breakdown should be attended immediately by the authorized trained personnel only. Okay, any robot handling tasks are clearly distributed to the operator, programmer, and system integrator. So set of jobs what an operator can do is clearly defined in the industry soft floor somewhere. Programmer can do programming. Their objectives and their functions are clearly defined. Integrators are the overall managers who integrate the system to other equipments in the environment, other accessories which are there in the robot, to the gripper, to the controller, to the linear rail maybe. Okay, so all the jobs are system integrators' job. they integrate the robot to other, like a conveyor also. So basically programmer comes below to that, who programs, he makes use of the integrated system, and operator, he finally runs the program only. He cannot further change the program or modify the program, or maybe reprogram the system also. Okay. Yes. Any modification to the structure of the robot is to be authorized by the manufacturer only, so that it performs to its fullest. Manufacturers, even after following all these above guidelines, please note, manufacturers, they do not guarantee that industrial robot will not cause any personal injuries or any material damage, even when all the safety instructions are followed. Okay, they cannot guarantee, because it is very much user specific. Okay, so they never guarantee for such. So that is the reason why safety comes in. You have to follow all the given guidelines by the manufacturer and the internationally recognized guidelines which are there. So we'll discuss upon that now. Okay, so conformity to the directives published by European Agency for Safety and Health at Work, as well as BIS and ISI, which is there in India. So these are some of the guidelines. So any robot as such is a partly completed machinery as defined by the EC Machinery Directive 2006-42 EC. So it says robot in itself is not a completed machinery, right? So the robot is to be integrated to other equipments in the environment, okay, so as to make it a complete system and fully functional. Let us say a robot without a gripper is nothing, right? It cannot do any job. Robot without maybe work table which is there, it is nothing. So it has to have a set of environments with which it is to be programmed, it is to be integrated so as to make it a complete machinery which does something, right? So if it is a spot welding robot, it has to be mounted with a spot welding system, not just the spot welding gun, right? Similar in case of any welding system, it can be a painting system, it can be anything, right? Even just a simple gripper is to be there. So as such, it is not a complete machinery, right? So together with other machinery, it constitutes a complete system, right? Safety functions and safeguards are required for operation are added as defined by the EC Machine Directive. The compliance to EC Machine Directive needs to be confirmed by means of an assessment of an authority, right? Of an authority. So that is a third party agent. It is not the manufacturer, it is not the user. So normally it can be a sub part of the industry which only does this job. They inspect whole of the machinery, its system, including the robot, and they basically confirm that whether it is conforming to the EC Machine Directive. Okay. This forms the basis for the CE mark of the system, right? What is CE mark? CE mark is European conformity. It appears on any commercial product that are traded on the extended single market in European Economic Area, okay, EEA market. If it is targeted for that, it has to be CE certified, right? You must have seen sometimes even in your mouse, it may be written somewhere CE symbol is there. So that is also the same. In India, it is also required to comply with the local standards like Bureau of Indian Standards BIS or Indian Standard Institute ISI marks. Okay, in India this also is required. Okay, so there are few important terminologies that we'll discuss now. Okay, so basically triggers for stop reaction, we'll discuss this also. Stop categories which are defined as per ISO 13850, that is safety of machinery guidelines. Okay, first of them is danger zone. It is the robot workspace and the stopping distance. So let me just show you one picture over here. So this is here. So you see danger zone is marked over here as green. Okay, that is in front of the robot, that is 1 is the danger zone, where a human should not enter at any cost. Okay, when the robot, as long as the robot is on, you cannot enter that region. Okay, so that is the danger zone. It is the robot workspace and the stopping distance also. If at all you apply a brake, it takes some time to stop. So that distance is known as stopping distance. Okay, so stopping distance, that include the reaction distance. So the time you sent the stopping command to actually when it started reacting to it. So that is the reaction distance, and when it actually applies the brake, it further gets carried off to certain distance. So that is the braking distance. So reaction distance and the braking distance combined together is the stopping distance. So this is part of the danger zone. So apart from the robot workspace, stopping distance is completed. Okay, so that is whole of that is 1. Okay, so stopping distance here is 2. Okay, so 1 and 2 makes it completely a danger zone. Okay, so robot workspace is the front one. So it may be possible that first axis go more than 180 degree as it is marked in this. So it can further increase also. It can be sometimes for software limited to not to move beyond this boundary also. Okay, so this is a stopping distance. Finally, the safety zone is the zone outside the danger zone. So that is the region 3, which is here, where human can at least get in, but definitely not when the robot is running. Okay, so in that case, the opening that you see from where human is entering here is shown. So that is, there is a gate where you have safety interlock. If you open that gate, the robot may stop also. Okay, so now talking about stop category 0. In this case, these stop categories are defined, stop category 0, 1 and 2. These are defined as per ISO 13850 guidelines, that is defined in the safety of machinery guidelines. Okay, so that is safety stop category 0. This means the drives are deactivated immediately and the brakes are applied. The robot performs the path oriented braking. In this case, let us say if it is a welding robot, it was maintaining a path, it won't maintain that. Okay, it can just try to stop as early as possible. So that is stop category 0. Okay, so the robot performs a path oriented braking. This is triggered upon releasing the drive's enabling switch. There is an enabling switch in the back part of your teach pendant. If you can see that, I will show you that. Okay, so if you just release that enabling switch, so what happens? It will immediately apply stop category 0 braking. Okay, switching off the robot. If you switch off the robot, stop category 0, it falls under the stop category 0. Power failure, any encoder error, you see all these falls under emergency braking. Okay, in this case, if robot continues to work, it is very much hazardous, right? Mode change, there is a mode change switch in top of your teach pendant. If you change that mode, stop category 0 is applied, and or pressing the emergency stop switch. In this case also, stop 0 is applied. Okay. Stop category 1, in this case the robot performs path maintaining braking. So in case of a welding robot or a pelting robot, the robot will try to, without deviating from the actual path which it was maintaining, it will try to stop the robot. The drives are deactivated after 1 second and then the brakes are applied. It is reasonably safe, you see. This is not an emergency, but due to some reason, somebody might have pressed emergency stop switch. This is triggered upon opening the safety gate. So as soon as you open the safety gate, you need not enter into the robot workspace immediately. So there is some gap which is there. So that is the reason stop category 1 is applied in this case. Pressing of an emergency stop switch intentionally, not in case of actual emergency maybe. In that case, stop category 1 is applied. Stop category 2, the drives are activated and no brakes are applied. So this is normal braking basically. The robot stops with the normal braking ramp. Maybe your program has finished. Okay, it has done its job. So that is stop category 2. So all these stop categories are defined in ISO 13850 safety of machinery guidelines. Okay, and this is stop category 2 is triggered upon pressing the stop switch or releasing the start button. Okay, so you don't intentionally want the robot to run, so you will release the switch, or you just press the stop button, or the program stops normally. So in all these cases, stop category 2 is applied. Okay, so these are the robot zones that we have seen just now. The workspace is safeguarded using appropriate human barriers like fences or a cage. You have seen in the small video that I showed earlier while we were starting this module. Okay, that is robot workspace. So that is this space. Stopping distance, that is this space. Okay, and the safety zone, that is this space. Okay, any workspace entry gates with safety interlocks, so that goes here. So these are the any gates will go here, are placed here. They are normally having interlocks which are there. It may have some limit switches. As soon as you open the gate, brakes are applied. It gets into one of the stop category that you have seen earlier, the previous slide. So axis 1, you see the major movement that takes you to different zones is axis 1. That is the first axis which is there in the robot, that is vertically upward. Okay, axis 1 may be limited using software limits to restrict the robot entering into forbidden workspace. So this may be one of the forbidden workspace where you may have some objects also. Okay, you don't want your robot to go there. In that case, axis 1, that joint angle may be limited. Okay, that feature is there in the robot. We have discussed it earlier. Okay, external safeguards, mostly the gates, must meet the requirements of EN 953, that is safety of machinery guards, that is for the guards. Okay, so let me just vanish a bit. Okay, so external safeguards, the gates must meet the requirement of EN 953, that is safety of machinery guards. So now let us discuss some of the safety functions which are already there in the robot. In any industrial robot, safety functions conform to the requirements of performance level D and category 3 of ISO 13849-1 2023. So this is the latest one which is there till date, safety of machinery. So all the guidelines are here. Okay, so the first one is mode selection switch. So what is mode selection switch? Just see in this image. So you see you have a key which is there, and you have that can turn to 3 positions. One is remote mode, play mode, teach mode. So there can be different other modes also in case of different robot. This is from Yaskawa GP12 robot with YRC 1000 controller. Okay, so this is the mode selection switch, and then you have operator safety that is connected to the guard interlock. So that is there in case of the gate. If it is there, as soon as that opens, so there is an interlock that stops the robot. That is for the operator safety. So that is there. And local emergency stop switch, that also you have seen. So you have emergency stop switch on the teach pendant. It may be there locally somewhere in the workspace, outside the grill maybe. Okay, it can be placed at different locations depending on its use and the user flexibility. External emergency stop switch is also there, that is outside the fence or the gate, on the teach pendant and on the control panel. So at least 3 of them is always there, that is outside the fence or the gate, on the teach pendant and on the control panel. So on the control panel is called as a local emergency stop device, whereas others are known as external stop device, emergency stop device. Next is your enabling switch on the teach pendant, that is for the servo. So it is this. So you see on the reverse side of your teach pendant, there is a switch which is black rubber thing that you can see here. So that is enabling switch. As soon as you press that, so it starts. If you further press it down, it is a 3-stage switch. So that has 3 states. So when it is normally it is off. As soon as you press it, it is on. If you further press it down, it will be off. So it has 3 positions. So first is to enable the drive. So in case of panic, either you throw it off, in that case also it is off, or if you pull it further as if you are in panic situation. So even if you pull it further and press it further, it is in off state. So you have to be very conscious to keep it on. Okay. So that is what is enabling switch, that is there on the teach pendant, that is for the servo. So that is shown here in the teach pendant reverse side of it. You see you have a hand strap from where you can insert your hand from the front and you can press the enabling switch. Okay, so that is there. And you have external enabling switch also, that may be there outside the cage, outside the grill also. So that is there. And you have local safety stop via any qualifying input. So it can be possible that some other machine is controlling this robot. Okay, so maybe that input is a qualified input that can trigger the safety stop. Okay, so that may be triggering any other safety which is there in the environment. So it is taking care of that. Maybe your conveyors has some problem. Okay, there is any proximity switch that has detected some failure in the conveyor. Okay, so that input can also be fed to the robot, so that robot also stops in sync with the conveyor. Okay, so local safety stop via any qualifying input can also be there. So these functions are handled by the dedicated electronic safety circuit which is within the robot controller. It is there. It continuously monitors the system, that is the robot, while the robot is working. As long as the robot is on, it keeps on monitoring all these switches. Okay, so these are known as the safety function. Various function tests are carried out before startup and recommissioning. So as soon as you install your robot for the first time, there are safety function tests. So that basically checks each of the functions one by one and confirms whether they are all working. So after startup and after recommissioning, that safety function tests are to be carried out. That provision is there in the robot itself. So yes, this is mode of working. Various modes are shown here. So this is your key which you can see. So it is normally a key. Once it is put to one of the mode by an operator, so operator normally works in the play mode only. Okay, operator comes here. A programmer can take it to this also. Once programmer is done with his job, he will turn the switch to this position and take out the key, keep it with him, so that the operator can only run the program which he has already done. This is a remote mode. A programmer can also put the robot to remote mode. What is remote mode? In this case, the robot is run by any external inputs. Okay, it may be by some proximity switch you are getting the signal or something like that. Okay, so one by one we'll discuss on that. So this is the mode switch which can go to remote mode, in which the robot runs its program by external inputs and outputs. And you have a play button also, that is an operator can run this play button. Okay, he can execute any code if it is there, any program if it is there, which is done by the programmer. Operator can use this mode, and programmer normally takes it to the teach mode and does the programming. Okay, so operator can also handle start button and the stop button if it is in play mode. So mode will govern what other switches will be active. This is active always, but this is active only when it is in this mode or this mode. Start switch. This basically starts the program. If a programmer has programmed to do certain operations, okay, so this is the switch which actually starts it. Mind it, this is for GP12 Yaskawa robot with YRC1000 controller. The switches are very much the same for other robots also. For maybe Kuka robot, for Fanuc robot, things are very much the same. Locations may be different, or orientation of these may be different. This key may be at the top somewhere, emergency stop may be located somewhere over here, but idea remains the same. So nothing very specific to Yaskawa over here. So start switch, normal or slow operation depending on the play or teach mode is selected. So start switch, if you press this button, if the robot is in teach mode, the robot goes very slow to confirm whether the program is correct or not. So that is in case of teach mode. But if it is in play mode, as soon as you press start, robot does the job to its full potential and full speed. Okay. Even in case of remote mode, robot works in the full speed. Only in case of teach mode, start switch will take it to slow speed. Okay, slow speed, so that you can observe whether it is working correctly or not. Okay, so that is the start switch. Similarly, you have a stop switch, that is to stop the operation, and emergency stop switch, that is in case of any emergency or while you are leaving the robot without any job to be done, you can keep it pressed. So you know there are at least 3 locations where you can find it. This one is on the teach pendant, and you also have this outside the workspace, outside the cage that you have seen, and it is also there on the top of the controller. Okay, hardware controller that is there for this robot. Okay, the switches are very much similar in most of the industrial robot. Okay, modes of working. Okay, so what are that? So you have additional safety modes, that is there. Jog mode. What does the robot do in case of jog? There are various jog button, you see. So this is for X plus, X minus, Y plus, Y minus, Z plus, Z minus, right? And there are axis jogs also. So that is there, that enables you to do programming very easily. It can move the robot safely. So this is also considered as additional safety thing. You need not take the robot to one place to other by any program. You can directly use these keys and take the robot safely till those positions. So as long as you keep this button pressed, it is on. If you release it, it is off. By default, it is off. So this is a jog mode. And you have software limits also. Software limits are there. That is there. You have learnt earlier also in one of the module, when you can limit the joint motions, okay, to move within certain angle only. It won't go beyond certain angle. Let's say if it is a first joint, you want it to go plus minus 90 degree. That is only in front of the robot. You want your robot to move. It won't go behind. Right? So that can be done. That is through the software limit of the axis 1. You can also define a workspace where you have a cuboidal workspace, and you can restrict your robot to entering into this cuboid. There may be some object which is there. Okay, or you can program your robot through software limits to work only within this cube. Robot won't go out also. So that also is doable. So that is known as software limits. In Cartesian as well as in joint mode, it is possible. Mechanical end stops are there. By default, joints, they have mechanical end stops, but that is not very safe to use. You should not take your robot to those mechanical end stops. Once it goes there, robot can lose its mastering also, right? Due to the high amount of jerk which is there once it collides with that mechanical end stops. Okay, external couplers are there, so that can be coupled, that can be used to connect the robot to any external input and output. So those couplers are there, that I have shown you while introducing the robot in one of the videos in module 1. Okay, so using those external couplers, you can take input and output from the environment, from other equipments which are there, which are also integrated to the robot. So that is external couplers. And there are labels. This is very important. They are passive safety features. Okay, you have rating plates. You have rating plates that basically states what is the rating of this robot, so that you don't connect this robot to a low rating supply. Okay, warning labels are there, safety symbols are there, designation labels, cable marking, identification plates, what kind of robot it is. So all these labels are mandatory as per the safety guidelines of the manufacturers, as per ISO guidelines, and also as per the company which is using this robot. So it is mandatory to be there. Okay. Apart from these, please note different operating modes, they activate different safety functions. So if you see you are switching to mode to this will enable, let's say, few of the buttons. Let's say start and stop switch is only activated once it is there in play mode. Otherwise, in case of remote, once it is started, it is on forever as long as you change the mode. Okay, similarly, start and stop switch is activated and deactivated. That depends on what is the mode. Okay, same with emergency stop. Emergency stop is on always. It doesn't depend on the modes. So now let us talk about the norms and regulations which are there that actually covers all the things that I have talked so far. So first of them is 2006-42 EC, that is the machinery directive. So the statement that I said, the robot is a partly completed machinery, that is actually defined here in this directive, machinery directive. This is an European directive. So that actually states, and you can understand as well, robot by itself is not a fully functional machine, right, without having any attachment to it, right. Next one is EC directive 108, that is EMC directive, electromagnetic compatibility of the robot controller. So that is defined here, right. And EC 2397, so that is the pressure equipment directive. This applies to the robot that are equipped with a hydropneumatic spring or a gas cylinder counterbalance system. Normally you see your robot is counterbalanced by its own link. Okay, so extension of this link normally has, you see, you have motors which are hanging here. So whatever load that comes here can be compensated by additional load that goes here. But this is not always possible, at least in case of this. You see, you have whole of spring loaded spring mass damper system which you see here. This basically is the gas cylinder counterbalance system. So in order to design this, in order to maintain this part, you have to dismantle this. You should be familiar with pressure equipment directive, that is EC 2397 guidelines. So 97 here means it is established in the year 1997. Okay, same here in 2004 and 2006. And then you have EN 614-1, safety of machinery, ergonomic design principles. So here everything related to ergonomic aspects of the robot is designed. So that is for the sake of safety of this machinery, that is the robot which is here. ISO 10218-1 2011, safety requirements of industrial robot. That is what is to be followed by all these guidelines that is put forward to you now, that is put to the poster, that is followed by the manufacturer, by the maintenance engineer, by the manufacturer of the robot, everyone else who is using this robot. Okay, ISO 12100-1, that is 2023, and -2, that is in 2012, that is safety of machinery, safety related parts of the control system. So it includes general principles for design and validation. So for the design, this is there, and for validation, the second one is there. So these two ISOs clearly define the general principles of design and validation of safety related parts that are related to the control systems. And then you have ISO 13850, established in 2015. That is, actually it is not established in 2015. This is the latest one which is here. Okay, that is followed till date as of now. Okay, there was much earlier revisions also that finally is updated, and it is at this stage now. This is what is now followed. Okay, safety of machinery for emergency stop function, principles of design. So all the stop category 0, stop category 1, stop category 2 is defined in this particular ISO guideline. Okay, and then you have IEC guideline 60204-1 in 2018, that is safety of machinery that treats robot as an electrical machines. General requirements are all discussed here. So even the robot, if it is electrically powered, so it is an electrical machine, so it has to follow this guideline also. Okay, and then you have IAC 61006-2, that is in 2016, and 61006-4 in 2011. So they basically discuss electromagnetic compatibility EMC guidelines. Okay, the general standards for immunity and emission standards for industrial environments. So both of them are discussed in these two ISO standards. So what is IAC? Basically, IAC is International Electrotechnical Commission, that is there in Geneva, Switzerland. It was founded in London, UK, and later on its headquarters are in Geneva, Switzerland. Similarly, EC is directives of the European Parliament and the Council. So E and C is here. Okay, so that is all. So that is for EC directives that is there. Okay, all these norms basically lay up the foundation for safety of human in the workspace. Okay. Okay, so that's all for today's class. Thanks a lot. So in the next lecture, we'll see how industrial robots are programmed. Okay, that's all. Thanks a lot.